Okay, so we are on to the finishing off chapter 1 here. So example C. The next thing we're dealing with here is radicals. So radicals meaning you've got this weird, you've got a root or a fraction in the power. Oops, you need to see the rule for me to talk about it. So here's the rule. If you have some number or some variable to a power, and that power is a fraction, this actually gives me a root. So m stays as the power up top, and n becomes the root that it's being applied to. And notice here, it doesn't matter if m is inside the square root or if it's outside. It's gonna give you the same thing. So we need to look at some of these here, and so you can see the difference between them. So this is in the power or an exponential form. So with this power, using the rule we have, so the denominator here, 3, becomes the root, so it's the cube root of 8 to the power of 2. Again, I can put it here, or you can do it as like this. I personally like this one, then I don't have to write the brackets, but up to you. And then evaluated form. So evaluated form just means do this. Put in your calculator, what does it get? 4. So that's what you're doing for that. You can continue on with stuff like this. So let's just do another one. So here, the negative one. So we've got the cube root of negative 27 to the power of 4. But mister, you're not allowed to have negative numbers inside of a bracket. Well, this is a power of 4, so that's going to cancel out. Also, you can have a negative in the root if this root is an odd number, just as an extra tidbit in there. You don't necessarily need to know that, but just as an extension there. So plug this into your calculator, and you'll end up with the evaluated form of 1. What if we have a fraction? Well, 16 to the power of negative 3 over 4. Let's just expand this out further. So we're going to have the fourth root of 16 to the power of negative 3. So the negative 3 just means you're going to flip that into a fraction. So in the end, when we evaluate it, it's just going to be 1 over 8. So notice we just have a fraction, and that's it. So not overly complicated. The radical form, you're just taking the base and it goes inside the root. Pretty straightforward. So let's flip over the page here. So now we're going to do the reverse of what we just did. We're going to take a radical and we're going to put it into an exponent. So we're going to make this into a power. And there's going to be a few things here that they're trying to trick us with. So first things first, we got the fourth root of x cubed. So x, that's our base. The power is 3 over 4. So that gives us what we're looking for. Let's do this again. So let's do the radical on the inside first, and then we'll apply the outside power. So in the brackets here, we've got x to the power of 3 over 5, all to the power of 5. Remember what we said with our power to a power rule? We just multiply these together. So 3 over 5 times 5, well, the times 5 and then divided by 5 cancel, and I just end up with x to the power of 3. So this is going to be what the answer for this one is. Let's try another one here. So in the brackets, we've got x to the power of 4 over 5 to the power of 2. Multiply this in. Remember, this is the same as 2 over 1. So as I multiply it, 2 times 4 gives me 8. 5 times 1 gives me 5. So that's going to be our final answer. Again, D, this is an extension question. You can give that a try. Next, radical rules. Basically, the radical rule says if we're multiplying two things that have the same root, I can put them in the same root. And it's the same with dividing. As long as the root is the same, square root, cube root, 25th root, whatever it is, as long as the roots are the same, I can do that inside a single root, whether I multiply or divide. So looking at something like this, these two have the same roots. They're both cube roots. So because those are the same root, I can simply say this is the cube root of x to the 6 times x to the 5 inside that same cube root because the root's the same. So this gives me x to the, since I'm multiplying, I add the powers, x to the 11. So that is this way. Next one, oh, we got a problem. Now the roots aren't the exact same. I've got a cube root, I've got a square root. So in order to do this, I need to apply a different method. So instead of being able to do like I did here, which is the easy way, I need to first put these into fractional powers. So the first one here is x to the power of 4 over 3 times x to the power of 5 over 2. Well, that doesn't look so much fun. Remember what our rule for multiplying exponentials is. I simply need to add the power. So all I need to do is x to the power of 4 over 3 plus 5 over 2. You should hopefully remember how to add and subtract fractions. I need to make a common base. So in order to do that, times this by 2 over 2. So I'd get 8 over 6 plus, multiply this by 3 over 3, 15 over 6. We'd get 23 over 6. So I'd end up with x to the power of 23 over 6. Yes, you can have a really ugly function like this. So once I get here, be careful with how I ask you to write the answer. If I ask you it for in radical form, this is radical form. This is exponential form. Radical, exponential. So if I ask you for the answer in exponential form, write an exponent. If I ask you it for in radical form, write it as a radical. So be very careful when you're doing this to understand how this works. So you're going to apply the same method for the other two. For the sake of time, I'm going to leave that. You can do it as a practice problem. So here we go. We are going to simplify and rewrite without exponents. So if I say without exponents, that means in radical form. So in a question like this, yes, you could just type this in your calculator and get a final answer. And that's a great way to double check your answer. However, if you want marks, you need to show your work for this. So I will not give you any marks for this if you just write down the final answer. You need to make sure that you show me how to do that. So for this one, I need to add the powers, and notice the denominators are the same. So it's going to be 3 to the power of 2 over 3 plus 4 over 3. I can add that. That's 3 to the power of, at the numerator, 6 over 3. That I can do. You can simplify this to be squared, 3 squared, 9. So that's my final answer. This doesn't have exponents, so we're good. Let's try this one. Notice the bases are not the same. Because the bases are not the same, I cannot simply add the powers. So be careful with that. It's a trick. So what I'm going to do is I'm going to write this in radical form. So this is going to be the cube root of 2 squared times the cube root of 3 to the power of 1, which is just 3. And notice the cube roots are the same. If you remember from our radical rule up here, if the roots are the same, I can multiply what's inside. So I've got the cube root of 2 squared, which is 4, times 3 to the power of 1, which is 3. And I'd get this. and multiplying that out, cube root of 12. I can't actually take the cube root of 12, so I'm going to leave it as that. So notice when you're doing it, there are a few little oddities that you need to be aware of. If the bases are the same, you can add the powers. If the denominator of the powers are the same, you do it this way. So there's going to be a little bit of trickiness in this and figuring out which method can I use. So you really need to be aware of that when you're doing the questions. So for example, this one, bases are the same. So I can simply subtract the powers. This one, the bases are not the same. So therefore, I need to figure out a way to do this. I can do it as radical or another way, something like that. Same thing here. Bases are not the same. The denominator of these are not the same. Therefore, you need to find another way to do it. Either writing it out in radicals and trying to make the denominators the same, something like that. So I'll leave these ones to try. This really only comes from practice. The more practice, the better you'll get at this.